Okay, this will be the second part of 8.2 confidence intervals for proportions. So we kind of zoomed through all this stuff in the first part of the video, so if you need to take a look back at that, feel free. We did a little example here, and let's see, we did that was the homework. Okay, so a little activity we would normally do in class, we could give each group a little bag of M&Ms and try and figure out what proportion of the M&Ms are blue. So you would have a sample, and it would just kind of help to go through the process. You would create a confidence interval. So make sure you know first couple steps you would do. Go ahead and from your sample, from your bag, get a sample proportion. So in your own individual bag, what proportion were blue. And then we could actually just determine a confidence level. We'd probably use like a 95%. So you would need to know to use the 1.96 for Z star there. So your interval would end up being, your whatever your sample proportion was, plus or minus 1.96 times the square root of your sample proportion times 1 minus your sample proportion all over n, which was the number of M&Ms in your bag. So we kind of walk through that and check the conditions and make sure everything was met. So that was just a little in-class activity. But anyways, let's go back to the example we did. This was at the end of the first video. A poll found that 38% of 1,012 adults said they believe in ghosts, and we went through the steps to find a 95% confidence interval. And of course we had to check the conditions and everything. What I wanted to show you though, there is a way to do the actual getting the interval on your calculator. Okay, and I have no problem with you guys doing it that way. Just so you know, there will be some questions where you're going to have to show that you understand the formula and know the vocab, know the point estimates, the 0.38, know what Z star goes with 95% and all that stuff. But to actually get the numbers, if you go into your calculator, there's you press the stat button, go over to tests, and one proportion Z interval. So we'll show you where that is real quick here. So remember, this is how we found one of the Z stars. If you're ever needing to find a Z star, it's an inverse normal. But to do the interval, stat over to tests, and there's going to be a whole bunch of things in this list that we're going to be using pretty much the rest of the year. So you need to keep in mind there are a bunch of tests up top. The first 6 all say test at the end. That's going to be for a hypothesis or significance test. Starting with number 7 are intervals, and these can be a little confusing because a lot of them sound the same. Z interval, T interval, those are going to be for means in our next section. The 2 sample stuff is a couple chapters down the road. What we're doing actually right here is a 1 proportion Z interval. Okay, so just a little bit of heads up here. Z is always going to be for when you're using proportions. You're always going to use Z. With means, sometimes they use Z, sometimes they use a t-test, and we'll talk about that again later on in the next section actually. So, but for now, it's just a 1 proportion. Okay, the one right below here, in case you're wondering, a 2 proportion is let's say we were trying to estimate the difference in 2 different population proportions. But right now we're just dealing with the 1 proportion Z interval. So we would just go right in there, and it's basically set up where you can kind of just plug in how many out of n. So in our case it was 38% of 1,012, and then the confidence level, you can just type that in. So this would actually look like, in this case, again, it was 38% of 1,012, so the x actually needs to be a count. So that 384 there, that is 1,012 times 0.38. Okay, it's 38% of the 1,012, so it's not a percentage. It's more of a number of successes, kind of like a binomial, right? It'll be 384 out of 1,012. You can check that that is 38%. So sometimes you need to do that calculation, and you can do it right in your calculator. You can do 0.38, do it in this, right in this line here, times 1,012. And I believe it does need to be a whole number, so there may be a time when you need to round if it's not. Yeah, so let's round that. So I think you could use 384 or 385, either way would be fine. And then put in the n was 1,012. And then whatever confidence level, and in our case it wanted it to be 95, make sure that's a decimal, it's 0.95. But that could be 90 or 99 or basically anything you want. And when you go and calculate that, it's going to go ahead and give you right up top here, this is the actual interval we got. Okay, we had rounded it, I believe, to 35 and 41%. Okay, so the calculators can really be helpful, and feel free to use those to do that. We're going to be using a lot of it throughout the course. Okay, so one other thing here. Let's say a poll is taken to find the proportion of adults who approve of attempts to clone humans. And this is one of those, what sample size is necessary? Let's say we want to be within 0.04. We want the margin of error to be only 4%. Okay, so of course larger sample sizes give you smaller variation, right? So what kind of sample size would we need to get this 4%? So basically, remember the margin of error, this is the thing after the p hat in the formula, right? This is z star times the standard deviation. All of that's called margin of error. Okay, so they gave us a 95% confidence level there, so I know what the z star is going to have to be. Okay, n is the unknown piece. P hat, we don't know either. Okay, so we need to think about this. Um, we haven't even taken a sample yet, so we don't have p hat. Remember, this is in this formula, it's usually p's, and we were trying to use p hats to estimate it, but we don't have either one. So here's what we need to think about, and this is a little bit confusing, but what p hat should we use? I mean, we have to use something, right? So if we start thinking about the way the formula is set up, if we go back here, the top is always p hat times 1 minus p hat, right? So if p hat was, let's say, 0.2, the 1 minus p hat would be 0.8. So what I do is I'm just going to try and play around with some of these numbers just to see what happens. What would happen if I used, what if p hat was 0.1? Okay, and again, I'm just kind of deriving something here just so you can see what we're doing. So if p hat was 0.1, then 1 minus p hat would be 0.9, right? And that would give us in the numerator a 0.09. That would be the value up here. Okay, what if it was 0.2 and 0.8? What if p hat was 0.3 times 0.7? So what ends up happening, the greatest margin of error, the biggest that this numerator can ever be, okay, the biggest, again, that this numerator right here, the highest it could ever be is if p hat was 0.5. 0.5 times 0.5 is the biggest that numerator will be. So what we kind of do is that's kind of our safest value to use. It's the most conservative. Okay, it's going to ensure that we don't underestimate anything. So when you're seeing a problem like this, you're just going to have to use 0.5 as p hat and go into the formula. And it's just going to make sure that we have a big enough sample size. It's just kind of like, this is like the worst case scenario, right? It's the safest. Okay. So what we're going to do again is, and here's our problem. We want 0.04 to be the margin of error. Okay, and we know z star coming from the 95% is 1.96, and we will always just use 0.5 and 0.5 for both of these. Okay, anytime you're trying to find the sample size, that's just the the safest way. Just use 0.5 and 0.5. Okay, because again, remember, we just don't know a p hat. We haven't taken a sample yet. So when you're kind of stuck, that's what you got to do. And now this is just going to be algebra. I would divide both sides by the 1.96. Square both sides, all that stuff, and you should end up with 600.25. So that would be the sample size necessary, and you just got to keep in mind here 600.25. You normally would round that to 600, but in this case it's saying like 600 is not quite enough people. So even though it's only 0.25, we're going to round it up to 601 subjects. Okay, a little shortcut. If I know some of you guys are kind of more into formulas and stuff, this one's actually solved for n. It's the same formula that's highlighted here in green. It's just already solved for n, and the 0.5 times 0.5 is already multiplied out because that's always going to be 0.25. So if you just want to use this, you can just throw whatever the margin of error that's given in the question and throw in the z star down here depending on the confidence level, and this will actually solve for n. Okay, so that's kind of the end of 8.2. Read over that. There's a good example in the book, a few problems from the book that you can begin working on, and then there's also the multiple choice review PDF that I'm going to upload for you guys. Okay, all right.